All right, everyone, let's get started. Please download Laboratory 27 from Blackboard. And today we're going to learn linear regression model. As usual, you need to run the first script and input your name and number, title, and date, okay? So today, first let's go over some terminologies about linear regression model. Actually, you must be very familiar, right? Because you learned from the lectures. So it's about the basic predictive and technique to analyze some data sets and to predict some variables, right? So actually, it's designed to use the linear regression model to use a linear formula, right? So it means you need to have a slope and interception. Here we represent the slope as beta, interception as alpha, right? And our goal is to find these values for the parameters alpha and beta, minimize the difference between the observed raw data and the predicted data, right? If we are able to determine these values between the data, between the parameters, we can get the best fit of the line, right? Predict the values y and x. And how to estimate alpha and beta? In today's class, we use a method called ordinary least squares. Actually, there are many different methods to solve the questions of linear regression model, and we choose one called ordinary least squares. It means we want to, the objective of this method is to find the values alpha and beta, minimize the sum of the square the difference between y and ye. Means here each difference, right? Suppose we have four elements in y, in observed raw data. And from this linear regression model, we can get the four difference, right? For the same x-axis, you can check the y-axis, y value for ye, right? And then you can get the difference. And after that, you can use the square difference and find alpha and y that minimize the sum of the square difference, okay? And in this one, we need to use actually from it's solved in mathematics, right? So the result of the formula would be beta would be the sum of each element of x minus the mean value of x multiply y, each element of y minus y, mean value of y, and divided by the squared of the difference between each element and the mean value, okay? And after that, you can also use the formula to get the alpha. So alpha is dependent on beta. So if you can get the value of beta, you can easily to get the value of alpha, right? So here x bar is the mean value, and this is the mean value of y. Beta is covariance of x and y, covariance, and divided by covariance divided by the variance x, right? So next you need to know what is covariance, right? Covariance formula is this one, right? So, and the variance of x, yeah, so they are all mathematics and correlation. So it's the positive, zero correlation, and negative correlation, right? And the coefficient, you need to know how to calculate coefficient, but you don't need to do it by yourself. You can write Python codes to do that for you, all right? So let's see one concrete example. Suppose we have a table about the time and speed, right? And first one, we need to create this data frame for experiments, right? So first one, we need to import necessary packages, NumPy, Pandas, Matplotlib. And next one, we need to create two lists and create a dictionary, right? So we use a dictionary to store all these two lists, and then we can create a a data frame based on the dictionary, right? And you see the result, okay? Time and speed. So there are only there are 2 columns and the 10 elements, right? Oh, sorry, not 10, it's 11 elements. Yeah, so you can use describe to get some summaries about the data. And after that, you can use the statistics dot variance, time and speed, variance, and the print out result, okay? Whereas time var, you can use the statistics, it's very convenient, right? And then you need to know the relationships between the time and speed. So in this way, if you want to find out the relationship, you need to get the covariance. So it means you need to use the time here. You need to use the data frame dot covariance. And for the first element of the first row, it would be time and time. So it would be, it's the same as variance, right? Because the covariance between time and time is just the variance, because these 2 lists is the same, they are same, right? Next one, you see the covariance is this way, right? And you can also use the Pearson method to know the positive or negative relationships between that. So you see the time and speed, they are 0.96. It's pretty high. It's nearly 1, right? Nearly 1. So it is a positive relationship. Okay, so next one, we can use the covariance to compute that to get the beta and alpha to determine the linear regression model. Okay, so any questions so far? Okay. And next one, we need to do the linear regression with some basic Python codes. Estimate the y, use the ordinary least squared method. We need to compute the x mean and y mean first, and then covariance, get the covariance and the variance, and you can get the beta, and based on the beta, you can compute the alpha value. So first one, you need to get the mean value of x and y, right? Mean value, time, and speed. And after that, you can get xy covariance, use this way. Each element difference with this one and multiply this one, right? And next one is square root. Actually, you can also write as this way. It's the same, right? With the formula. So it's the same. Actually, it's the same. It's the same, right? Use a squared. And they are all come from here, right? We just use this covariance, variance, but we need to do the sum, right? That's why here after we get this one, we need to dot sum again, because they are least, they are not only one number, they are multiple numbers. So sum and divided by this sum, okay? And after that is about the beta value, and next one is alpha value. Alpha is y mean minus beta multiply x mean value, so times, so here, right? It's about the x value, alpha value, sorry. And you can print out what is alpha and what is beta. It's about the second, it's about the how to compute alpha and beta and determine the linear regression model with basic Python codes. So any questions so far? Okay, next question is what we can do with this linear regression model, what we can predict, right? So we have an estimate for alpha and beta. Model can be written as this one, right? This model, make any predictions. For instance, you can create a list, right? It's the list of this x is the list of this all this time, and after that you can compute the predicted y as this way, right? And you can also use the prediction against the actual value of y and get a better visual understanding of our model. right? So it means you can you plot a scatter plot. You plot this regression line first as a red line, and then use a scatter plot to plot the 11 dots in this figure and check the difference, right? So create a Canva, plot a regression line, and plot the scatter plot, X label, Y label title. See 11 blue dots, right? So you see this one is it's not the best, but it's a good fit, right? So you can see the difference is not very large. Okay, it's for, and so you see here red line is a best fit, and it's a fit, and we can predict y from any value of x. So for instance, we can here we only have x to 10 or 11, but we can predict x to 20 or 100, any values of x. So we can predict this x as 20, and after that we can print the y predicted would be 224, right? 22. It's about the example how can we get with the linear regression model. Okay, so any questions so far? Okay, next one is actually we don't need to, so in this way we need to like create a data frame, we need to create a new list, we need to compute the covariance, we need to compute the square the difference, and then we get the alpha and beta, but we don't need to be so complicated. We can write only 3 lines to get the alpha and beta and get the regression model. Okay. So we can use another function from statistical models. Actually, this is a collection of different models in machine learning. So linear regression model is just a basic model, right? So first we can use this model function, a model package, and then we can use the OLS function. OLS is ordinary least squared, right? So if you forgot, you can see here, it's the OLS, least squares, there are least squares. OLS function to initialize this regression model and use your data to train it to get a better fit. And you can do that. So you can check the codes here, import statistics formula API, SMF. So actually import and rename it, right? And initialize and fit the linear regression model. Initialize means you can set a variable and use the SMF.OLS function. And here speed and time. So the first one is something you want to predict. Okay, so it's very important. And the second one is something you want to analyze based on. Okay, speed based on time, and data is an argument, and this data is the data frame, right? It's because we store it as the data frame. Data is data. So second one, you can revise it if your name is not data. Okay, and please make sure to use the right name and the right order. The first one will be the variable you want to predict. Okay, it's about the initialize, and second one, after you initialize this model, you can use dot fit to get a better fit, and after that you can use the we no longer have to calculate alpha and beta, because here a method does it automatically for us. So you can use the parameters to get the alpha and beta. Sorry, I forgot to write. Sorry. And right, so intercept and the second one would be the slope. So for instance, here you can check the alpha and beta. It's exactly the same. Okay, so it's the same. So you don't need to calculate it by yourself. You can just use this model, train this model, get the parameter, use this model. Okay. Okay, so next one we can, in this alpha is the intercept and beta is slope. So this alpha and beta, and after that you can compute you can plot the figure again. Oh, sorry. Here you can use the predict to get several values. speed predicted values predicted. Okay. And after that, it is a line, right? It's a line, and you can plot this regression line, new regression line, and check the difference. Okay. Spot the how to use statistics model package and use OLS function to compute that to get a linear regression model. Okay, so any questions so far? All right, and next one is about 2 exercises. So list some of the pros and cons of a linear regression. You can list anything. Make sure to set any resources that you may use. And second one is, how good do you feel about the predictive model we created in today's example? Will you trust it, explain it by using the plot? So you can explain from the difference between the raw data and the predicted data, right? So yeah. So please answer it by yourself, and please make sure to submit by the end of next Monday. Yeah, so that's all I want to share today. If you don't have any other questions, please feel free to leave the meeting. Have a good lunch and have a good weekend. Thank you, guys. Okay, so I will stop here. Thank you, guys.